Welcome to lesson 5B of this Arduino C++ course, and by the fact that it is a 5B, this is an extra lesson that has been put in at a later date, as I was asked an interesting question about how to control digital pins on the Arduino using toggle switches, and the code is slightly different to the normal momentary sort of press to contact buttons that you get in your normal Arduino kit. So let's have a look at this type of button. So on the desktop, I've got a few different buttons. These are sort of the standard buttons that you would get in your Arduino kit. They're the usual sort of press to make a contact. These are the sort of toggle switch type, and these are a little bit different. If I move this switch, it is a sort of on or off. It's not this sort of press to make contact. The contact stays there all the time. This is a slightly different type where it has multiple contacts. This can switch on or off, but two sets of contacts. And then there is another type here where it can be in the center, move to one side or the other side, and again it swaps between the contacts. The final one is similar to this, but two sets of contacts. Now, rather than me trying to explain exactly how all these different types of toggle switches work, I found this website by a company called Little Fuse, and there are some diagrams of how these switches and the contacts work, which are ideal for your sort of projects if this is the type of switch that you want to use. I have no affiliation with this company, but I found the link very useful, and I will put a link on the Digital Town website to these particular switches. So why would you use this type of switch rather than a push to make? Well, these do have some advantages in certain situations. Just going to pull into camera. This is an old model railway control panel. So I've just zoomed out to make it easier to see, but as you can see on this, what used to happen with the layout was different sections of the track could have power from one source on the left, one source on the right, or if I moved the button to the center, then no power was supplied to that bit of track, which is very different to these momentary buttons that were used to move points or turnouts depending where you live. So if you were upgrading an old model railway control panel, it would be very easy for me to remove all the complicated wiring out of the back of this and just put a simple Arduino control in instead, but still connecting to these, if you like, the more traditional style buttons. One other thing also to be aware of with this style of button, of course, if you compare it to these sort of quite cheap and nasty buttons that come in the kits, these buttons last a long time. This button here is probably about 30 years old and it's still working. I doubt if this will survive the abuse that this one has taken. So they are good quality switches when you can get hold of them. Now, as always, all the information for today's lesson is on the lessons page on the Digital Town website. Just scroll your way down to lesson 5B. You will find the circuit diagram. Click on the circuit diagram to get the larger version that you can just zoom into. Very simple circuit. I've got the toggle switch here. There are two resistors, 4.5 to 10K pull down resistors. So the pull down resistor means that it is going from the switch down through the resistor to ground. The center contact, and the way that I've got this wired up, is going to the Arduino 5 volts. So when power is flowing, then this pull down resistor, instead the reading here on this white or the yellow will go to pins 4 and 5, and that will let me know if the power is going through or not, basically whether the pin is sent high or low. I've also got two LEDs, a blue and a green, again with a 330 ohm resistor, so it is the long leg of the LED is pointed towards the Arduino. That is where, if you like, the power is coming in. It's then coming out, going through the resistor and down to ground. Also, of course, you're going to need the 5-volt and the ground connections from the Arduino coming down to the rail of your breadboard. Now, unfortunately, when I went to build this project, I realized that I haven't got any big breadboards, so I have put it on one of these tiny breadboards, and instead of using the switch itself, I am using just the two connections, and I am going to be touching directly onto the resistor to put the power through to the Arduino. It's a simplified version. It's just a mock-up of the switch, but it just made it a little bit easier to set up. So let's move over to the Arduino IDE and work through the code. Now, for those who are looking at their IDE and thinking your IDE looks different, if you go to File, Preferences, I have the dark theme rather than the normal light theme, just because it's better for my eyes. So if your IDE is looking different, that's the reason why. So the pins I'm going to be using from the circuit diagram is pin 4 for the left side of the toggle switch, pin 5 for the right hand side, pin 11 is going to control the blue LED, pin 12 is going to control the green LED. And so for those pins, I've set up an integer for the left toggle, the right toggle, the blue LED, and the green LED. And then in the setup, I've obviously started the serial monitor, and at the same time I have put the left and right toggles as inputs, which means that I'm now reading from those switches whether the pins are high or low, and then the blue LED and the green LED have been set as outputs because I'm going to be sending those pins high or low to turn the LED on or off. Now, scrolling back up, there are some other variables that I just need to explain. We have a left toggle state and a right toggle state. This is storing the state of the button or the state of the switch, and you'll see why in a bit. Also, we have current millis, which is going to be controlling the timing. Again, this is non-blocking code, state machine code, some people call it, or millis controlled code. And we're going to have button millis, which, just like in lesson 5, is going to be used to debounce the button. Now, I'm using a debounce of 350 milliseconds. Now, you might think, why do you need a debounce on a toggle switch? And it's quite simple. When that toggle switch goes over, even when I was trying to move them earlier, you'll notice they can take quite a bit of force at times. They've got quite a bit of spring in them, and it means that the contact can make and then break and then make again. And obviously we want a nice clean signal. We only want to read the on or off state once. So just by adding the debounce, just as in the previous lesson, we will get a much cleaner signal. Now, just one thing, going back to the webcam, I am pretending that I'm using this toggle switch. So if I move the contact to the center, there is no power going to either. Move it to one side is the equivalent of the power moving over here. To the other side, the power is over here. So if you like, I've got my left toggle and my right toggle. If I was using this type of toggle switch, which only has the 2 connections, then obviously you could remove the yellow lead and the 1 resistor because it wouldn't be required anymore. So coming down to the main loop, let's just work through the lines of code. The first line here is an integer button press. This stores the value that I get from the digital read, both for the left toggle and for the right toggle. Now, the advantage with this being a local variable is whatever value this finishes up with, when it gets to the end of the loop, this variable is destroyed and it restarts with a value of 0 all over again. Now, as in previous sketches, current millis is here to stay, and we are storing the time since the board started in milliseconds in this variable current millis. Then what we're doing is we are subtracting button millis from current millis, and if that value is greater or equal to the debounce time, which in our case is 350 milliseconds, then and only then does this bit of code start to run. If the button is within a debounce period, the button will not be checked. Now, the chances of you switching the toggle from one side to the other and back quicker than 350 milliseconds, if it's as stiff as the buttons that I'm using, that's not going to happen. Right, so let's imagine now that we are in a button reading period. We're going to get the value of button press, and the first thing I'm going to do is check if that value of button press is different to the left toggle state. So I'm looking at the left toggle first. Let's bring that picture back in on the webcam. So we are looking at this one over here first. So if the value of the switch has changed, so in other words, button press now has a different value to the previous toggle state for the left-hand side, then the first thing we need to do is reset the debounce so that it delays sort of a 350 milliseconds. And the other thing to do is set the toggle state to the new value, because obviously when this runs again, if I have moved the switch, I want the button press once again to be different to the value of the left toggle state. So I need to keep updating the left toggle state. Now, the other thing, of course, is if the button has changed, if the switch has changed position, we need to do something. So if the toggle is giving a value that is greater than 0, so in my case that would mean I've turned it on, the power is running, then what I want to do is I want to send a command to digital write the blue LED high. That means it will turn the blue LED on, and I'm also going to serial print to the serial monitor just that the blue LED is on, and then of course do the opposite if the toggle switch goes the other way. Now within this you could have multiple commands. You could be sending 3 or 4 LEDs in different positions, either high or low. If you're using servos, you might put a servo setting in, but this, if you like, within this if statement is where you would put your commands. So I've uploaded the code, and all I'm going to do now is pretend to throw the toggle switch. So as I now push that contact across, you can see on the serial monitor that the switch has been made, and it's saying that the blue LED is on, and obviously the blue LED is on. Move this away and the LED goes off because the button is now not made. And back again. Sorry about the flashing, I've got a bit of a loose contact somewhere. It's a bit of a battered old breadboard, this one. So that's how I've dealt with the blue LED, and obviously it's a little bit more of a long-winded way of doing it, but if you were doing multiple control items this is the way that you would want to write your code with your various control items within this if statement. Now, coming down to the right hand toggle, I've written it in a slightly different way. So here, this code only works if realistically you're controlling maybe a green LED or a relay or something like that. So once again, we're checking the value of button press, this time with digital reading on the right toggle switch. Again, if it's not equal, then we're going to reset the timer. You might think, well, hang on, we've already reset the timer, but only one of these items is likely to have changed in one go. We're then going to set the right toggle state to the button press state, and then all I'm literally doing is doing a digital write to the green LED of the right toggle state. Now, this works fine in this example, but this way of writing the code is faster, but in many ways not as good as this method here, because this only works if I want the LED to be set to the same digital state as the state of the button. So once again, the code is uploaded, and this time, of course, at this point, the system is the equivalent of the toggle switch in the center. As before, if I was to move the toggle switch over, then this is the equivalent that the blue LED would come on. Move the switch to the other side, and this time the green LED will come on. However, you'll notice on the serial monitor there is only an output for the blue LED, because for this green LED I use the simplified method of writing the control for the LED. So I hope that's been useful to you, and you can see that this sort of toggle switch has its place with the Arduino. It's different to the make to the press to contact type switch, but these definitely have their place. And one of the great things from a control panel point of view, of course, is by the direction you can see which way the switch is set. So that's the end of lesson 5B. Again, quite a short lesson, but hopefully a useful one for those of you who want to use toggle switches rather than the press to make style buttons. Certainly a lot of people in the model railway world prefer these sort of toggle switches. So that's it for today. I hope it's been useful, and I'll see you in the next video. Bye for now.